All right. Good evening, everyone. Sorry for the delay and also the limit to the class. I couldn't find any possibility to take more than 100 people, right? So at least for today, we'll be limited to 100 people. But inshallah, from next class onwards, we'll try to find a way to take more than 100. No, I'm not going YouTube live, right? Maybe from next class, right? Okay. So then, shall we start then? Wait, let's see whether we can do something. If we go YouTube live, the connection drops bad, right? So I don't want that to happen. Anyways, let's start, okay? We'll see from next week if we can do something. But for this, from this class onwards, we'll just keep it like that, right? Okay. Guys, just to give an introduction, most of you guys may be not from my class, might be new, right? So then main idea for this start is because I just seen mostly I see that you guys just attend the theory class. You guys don't attend paper classes, which I don't blame, no problem. You can do questions on your own, right? There's no problem at all. But you guys should understand one thing, the main the even before studying all of the theories, you should study theory, definitely, right? But the most priority should be at the end of the day, after whatever that you study theory, you should be able to face the exam, right? You should be able to do questions, right? So if you can't do questions, if you can't face the exam, there is no point in even studying the theory. Make sense, right? So all of that 1 year or 2 years of studies, let's say grade 10 and grade 11 put together, if you can't finally write the or do the question on the exam, there's no point, right? So the main thing, guys, remember, not only in mathematics, in any subject, not only in O level, in A level, in university, wherever you go, remember practicing question is is the best preparation for your exam paper, right? Not only mathematics, right? Not only in O level, in A level, university, wherever you go, whatever studies that you do, doing past papers is the best thing that you can do to achieve, or that is the best thing that will give you an idea about the exam, idea about the question, what type of question you can expect, right? So likewise, past paper is the best tool that you can use before you face your actual exam, right? So what I will doing this next 3 months, that is this November, December, and January, right? Only 1 month will be having, sorry, 1 week will be having only one class, 2 hours, not enough at all, right? This is just to give you guys a boost, just to give you guys a what? A small start, a kick start, right? So then, so that you guys will do the rest on your own, right? I'm just doing like 4 to 5 questions per week, right? Not enough at all, right? So I can't do the whole past paper. I'm doing classes, yes, you can join that, but this is just to give you guys a overall idea, everyone, right? Not only a few handful people, okay, right? First of all, is everyone, I'm clear, right? My voice is clear? Yes? Yes, okay, right. So you guys can drop a message whenever you have a doubt, right? Anyone can interrupt, talk. Yes, subject related. We have a little time to do whatever that we are planned to do, right? I have sent you 5 essay questions, right? So we'll try to finish that as soon as possible. I'm sorry for the delay, right? We'll start right now. Okay. So today the main target is two, right? Mainly the idea is algebra, right? Today we are targeting on simultaneous equations and quadratic equation. I have sent you 3 simultaneous equations and 2 quadratic equations, right? Well, let me drop a message on the channel saying that there's only 100 limit. Okay. So then take out the first question, right? So every question, I'll give you a small a map, right? If it's a simultaneous equation, yes, just a map, right? I won't tell you this is exactly what you should do. No, depends on the question, right? But I'll give you a map. Simultaneous equation, this is the idea you must have, right? Always the best thing is to think what to do next. You should know what to do next, right? If you know what to do next, you will always, you keep on work, you will not be stuck somewhere. What do I do? Right? You have a path, you have always have a map to each and every question, right? That is the idea here, right? So then, let's say the first question, take out the first question, guys, right? And also the reason I'm sending you the question on Monday and having the class on Wednesday is I'm giving you time for you to attempt the question before you join the class. Please, everyone, attempt the question and join, right? Don't join and then try to do the question when I'm explaining, pointless, right? That's not the idea, right? 2015, the fifth structure is a question regarding simultaneous equation, right? The students in a hostel. So what is the idea of simultaneous equation? A simultaneous equation means one equation having more than one unknown term. Now you guys think simultaneous equation means having two equations. No, wrong, right? One simultaneous equation means one equation has more than one unknown term. If one equation has one unknown term, let's say you have x plus 100 equals 400. You can see here this equation has one unknown term. You call it a simple equation, right? Now, if the same equation here has two unknown terms, then now you call this a simultaneous equation, right? Now, a simultaneous equation, definitely you can't solve this equation with one simultaneous equation, right? Now, just remember, when the number of unknown term increases, the number of equations that we need to find out or to solve this unknown term will increase. That means if one equation has two unknown terms, then we need two unknown equations or two simultaneous equations to find the value of the unknown terms, right? It makes sense. Now, one equation has one unknown term. One equation is enough to find that unknown term. Then when it becomes more than one unknown term, if we can see two unknown terms, you call this equation a simultaneous equation. This one equation. Don't think simultaneous means two equations. No. This one equation is called a simultaneous equation, right? So then when you have a simultaneous equation with two unknown terms, that means you need two simultaneous equations to solve or to find the unknown value, right? So now in your syllabus, don't ever worry, you will not get more than two unknown terms. Okay, so that means always you will have to build only two simultaneous equation. But when you go to A level, you have three simultaneous, four simultaneous. That's a different story, right? So in O level, you are stuck with, or you need only two simultaneous equations, right? Okay, now that in mind, a student in a hostel, the students in a hostel are to get new uniforms. Each girl is to receive a blouse and a skirt, and each boy is to receive a shirt and a pair of trousers. Okay. One meter of white material is required to sew a blouse, and 1.5 meter of white material is required to sew a shirt. You can see here, they're talking about white material, right? So then 1 meter of white material required for the shirt, right? And 1.5 meter of white material required for the blouse. Okay, next part. Moreover, 1.5 meter of blue material is required to sew a skirt, and 2 meter of blue material is required to sew a pair of trousers, right? Guys, if you don't have the question, I send it on the channel, right? Everyone on this channel, you can access the question. Please go on the channel. And you got the link, right? The same place where you got the link on the same channel, you have the questions, right? Go and check there, okay? So then you can see here the total amount of white 72. They have given you the total amount of white material. What does that mean? An equation should build in your mind. Now we are studying about simultaneous equation, and what today we'll be doing questions on algebraic equations. The whole idea is to make an equation where you have a left hand side that is equal to a right hand side. Now here they have given you the total amount of white material as 72. That means the white material used for boys and girls is equal to 72 meters. There you have built an equation. That's how you should work things out. Okay. So now see here, you have here white material, right? That is equal to 72 meters. That is for boys plus girls. The total your clothes required for boys plus girls. Okay. So likewise, for blue color material, that is how much? And total amount of material, blue material is 100 meters. Okay. So then for blue material plus girls, that is 100 meters. Right. Now you have an idea for one boy how much white, and for one girl how much white. Likewise, for how much blue for one boy and how much blue for one girl. Okay, one girl is given. Now the question says, taking the number of girls as X and the number of boys as Y, construct a pair. A pair means two, right? Construct two simultaneous equations. Okay, I will ask you a question. One boy, a boy. Sorry. One boy is Y, one girl is X. That's the number, okay? Sorry. Again. Right? One boy, if you take white color, we'll just deal with white color. One boy uses 1 meter of white. Okay? And one girl uses 1.5 meter of white. Right. If one boy uses everyone can talk, okay? If one boy uses 1 meter, yes, how many white material will two boys use? Yes?
Excuse me, sir.
Yeah.
Sir, the camera is not clear. The board.
Here the top part. Wait.
No.
Bandwidth is
It's
low.
like blurred.
It's blurred.
Is it blur?
Focused.
Is it still the same thing? Same issue?
Yeah.
Yeah. Okay.
So the camera
Wait.
isn't focusing.
Isn't focusing. Okay. No, it says for me the network bandwidth is low. Right? So maybe that's the reason. That's the problem. The same issue. No, what's the problem? It says your network bandwidth is low. Okay. Now is it better? Guys, now is it okay? Same problem. Please let me know. Is it the same issue? Or is it better now?
Sir.
Yeah, sir.
Yes, sir.
Same issue.
Okay, fine. Okay, good. So then, we'll go over the question again. So 1 meter of white is required to sew a blouse and 1.5 meter of white material is required to sew a shirt. The other way around, right? I've mixed it. So for a boy, you need 1.5 meter. For a girl, you need 1 meter of white material, right? Now, if you take blue material for one boy, requires how much? Moreover, 1.5 meter of blue material is required to sew a skirt. So for a boy, 2 meters. For one girl, 1.5 meters. Right. Now I'll ask you a question. Right. My question is for one boy, 1.5 meter. We'll go with the girls. For one girl, 1 meter. Then for two girls, how many meters? Yes? 2 meters. So 3 girls, 3 meters. 4 girls, 4 meters. That means the length required for one girl into the number of girls will give you the total length required for girls. Right? So see here, one girl needs 1 meter. They have told you take the number of girls as X and the number of boys as Y. For one girl, 1 meter. For X number of girls, 1 into X meters. So that is X meters. Right? So then I'll write it here. You can write for the white color, the material required for girls, 1 into X, that is total material is X meters. For example, let's say you need 1 meter. There are 50 girls. So totally 1 into 50, that is 50 meters. Same likewise, you do for boys. You need 1.5 meter. Now, the thing is, when you do equations, anything, this is a mixed fraction. You call it a mixed fraction. We have a whole number and a fraction. You can't deal with mixed fraction. You always convert it to improper fractions. This is how you do it. Multiply the denominator with numerator and add the numerator. 1 into 2 is 2, plus 1 is 3. So that is your numerator. So 3 is your numerator. Your denominator is 2, 3 over 2. Right? So for one boy, you need 3 over 2 meters. There is Y number of boys. So what do you do? Number of length required for one boy into the number of boys. So then 3 over 2 into Y. So 3 over 2 into Y. Right? This is the total white material required for girls, white material required for boys, then white material required for girls plus boys will give you the total white material. You can see we have built our first equation. So always think of an equation. When you think of simultaneous equation or algebraic equation, first thing that you think of, what is the equation I'm dealing with? That should be your map, right? So in your map, what now if it's a simultaneous equation, how do I build these two equations, right? So that should be in your mind. They will give you a total value. We'll see the next question also, right? They will give you a total value. That is your catching point, right? Here they gave you the value, the total value of white material. Okay, so you know the total value of white material. You find out what is that equal to. We know that is the white material used by boys and girls. We use in terms of X and Y, and we have built our first equation. We can do the same thing with the blue material. Right, so we know one boy uses 2 meters. There are Y number of boys. So total blue material for the boys, that will be 2 into Y, that is 2Y. Then total material for girls, again convert this to improper fraction. 1 into 2 is 2, plus 1, 3, 3 over 2. We have X number of girls. So then 3 over 2 into X, that is equal to the total blue material, 100 meters. Now we have two such equations. Okay, so then you have built two such equations. Now we are going to learn how to solve this simultaneous equation. Is it clear until this point? Any doubt here?
Excuse me, sir.
Sorry?
Excuse me, sir.
Yes, yeah.
Instead of converting it to mixed fraction in the first place, can't we do that while we are calculating it?
Yes, definitely. You can do that while you're calculating it. But why write the equation again? It's up to you, right? There is no rule saying when to convert it. You can convert it whenever you want, no problem at all.
Okay, sir.
Any other doubts? All right. Okay. Right. Right now, this first question only, I'm giving you more time to, how to build an equation. Next one, not like that. We'll go a bit faster. Okay. Right. Now we'll see how to solve any simultaneous equation. What's the idea? What's the idea behind simultaneous equation? Okay. Now we said that if we have a simple equation, one equation with one unknown term, easily we can find the value of that unknown term. But the problem here, we have two unknown terms in one equation. Now what we are going to do, we are going to use both the equation here and build a new equation with only one unknown term. So what are we doing? We are converting the simultaneous equation to a simple equation. That's the idea. Okay. We are using this both equation here, converting the simultaneous equation to a simple equation. What is a simple equation? An equation with only one unknown term. Okay. Right. Now here, that means we have two unknown terms. On the process, we are removing one unknown term, either x or either y. We'll see how we do it. Okay. Now here, when you compare both of this equation, we have 3 over 2. Right. Now that is a bit of a problem. Right. Now here, when you take the unknown term, the number multiplied with the unknown term. Now here, x is multiplied with 1. Y is multiplied with 3 over 2. Y is multiplied with 2 here. That number is called coefficient, right? Any number with an unknown term is called coefficient. This word you'll come across those words later also. So know the word, okay? Always learn new words, right? So coefficient means the number along with the unknown term. So here the coefficient is 3 over 2. Here the coefficient is 1. Here the coefficient is 2. Here the coefficient is 3 over 2. Now why I'm saying this is, if the coefficient has a fraction, then it is a bit of a problem. It's like a hindrance for us to solve the simultaneous equation, right? So the best thing to do for you is what? Get rid of the fraction, right? So get rid of the fraction. What does that mean? That means you get rid of the denominator. If you remove the denominator here, what will happen? This fraction will convert to a whole number. Now you have 3 over 2 here. How do you get rid of this 3 over this denominator 2? This 2, see here, this 3 is divided by 2. If you want to get rid of, what do? You do the opposite of the mathematical operation. If it's divided, what do? If you multiply this by 2, this 2 and 2 will get cancelled. The denominator will go off. That's what we are going to do here, right? To get rid of these 2 here, we are going to multiply the whole equation by 2. Okay? If you guys have learned equation, you might know the golden rule of an equation is what? When you do one change to one side, you're going to do the same change to other side. Why? You have to maintain the equal signs. Equal for a reason. Left and right is equal. If you multiply the left side by 2, right side also you're going to multiply by 2. Okay. So that means you multiply the whole equation by 2. Now we get, I'll erase the first part. Okay. Now we get another equation. See here, 2 into 3 over 2. Sorry, the top part you can't see because of the light. Okay. So 3 over 2x into 2. Sorry, 3 over 2y. Right? 3 over 2y into 2 plus 2 into x. Everything you have to multiply by 2 each term. So 2 into 72. Right? Now the same thing. Right now, if you multiply here, see here 2 and 2 get cancelled off. So you have 3y plus 2x, that is equal to 2 into 72, 144. We'll name it as our third equation. Okay. So then we'll do the same thing here. To get rid of this denominator, we multiply the whole equation by 2 here. Right. So now 2 into 2y, 2 into 2y. Now guys, also, I forgot to show you this. Every step, every change you make, you have to show, right? Now here what I'm doing, you're multiplying the first equation by 2, right? Next what I'm doing, the second equation, you're multiplying by 2 also, okay? Then 2 into 2y, that is 2 into 2y plus 2 into 3 over 2x, that is equal to 2 into 100. So now 4y plus 2 and 2 will get cancelled, 3x, that is equal to 200. We'll name it as our fourth equation, right? Now the board is small, okay, so I'll keep on erasing things, all right? So then this first and second equation now no longer we need. Why? We have converted the first to the third, second to the fourth. Now we'll be using the third and the fourth equation. Okay, this should be part of the answer, yes, but now we need the third and the fourth equation here. Okay, right. Now see here, third and the fourth equation. Now what do you have to do? What is the idea? You have two equations with two unknown terms. Now the idea is to convert this simultaneous equation to a simple equation. That means what? Either we have to remove x here or we have to remove y. That should be the idea. Okay. Now you're going to remove x or you're going to remove y. It's up to you. It's your choice. You can remove, you can decide to remove whatever you want, but always choose the easier option. What is the easy option? How do we know it's the easier option? Okay. Now, one thing, if you're going to remove x or y, definitely in both the equations, right? Now, you're going to use both the equations. For example, let's say you have 2x here in the first equation, right? Now you have another equation with 2x. Now, how do you remove this? How do you remove the x here? That means if you subtract both the equation, you can get rid of this x here. Why do you think of subtraction? If both of them are positive, you subtract to get rid of this x. Now, two things you have to understand here. One, both of the equation, the x has the same coefficient, right? You can see here, x has the coefficient 2 here, x has the coefficient 2. That means the first thing you have to understand, to get rid of an unknown term in both the equations, the coefficient should be the same. See here, y has 3, y has 4, x has 2, here x has 3. So in both equation, both the unknown term has different coefficient. So first thing you're going to do, you pick. Now we are trying to pick which one to remove, right? To pick which one to remove, first of all, both of them should have the same coefficient, right? Now to convert both of them to the same coefficient, tell me 3 and 4. Now, if you have two numbers and you think, okay, how do I make both the numbers the same? That means 3, you have to convert to a number, and 4, you have to convert to the same number. What hits your mind? What is the tool you are going to use to find the same number to two different terms? Now, for example, you have a fraction, two different fractions with different denominators. To add the fraction, you know the denominator should be the same. What is the tool you think of?
LCM.
Very good. You think of LCM, the least common multiple, right? So in this multiple, now 3, if you take, what are the multiples? 3, 6, 9, 12, 15, likewise 4, 4, 8, 12, 16, likewise. In that multiple, what is the common multiple? So 3 and 4, if you do the LCM, you get 12. 2 and 3, you get 6. So then think, is it easier? Do you multiply with smaller numbers to get 12, or do you multiply with smaller numbers to get 6? Definitely, you multiply with smaller numbers to get 6. Always make your calculation easier. So in that case, we are going to decide to remove x and not y, because removing x takes less effort when we compare to removing y, because removing x means we have to convert 2 and 3 to 6. Removing y means we have to convert 3 and 4 to 12, which will take more multiplications of larger numbers compared to removing x here. Okay, so we are going to go with removing x. That means if you need to remove x here, first of all, in both the equations, x should have the same coefficient. So 2 and 3, the same number we can reach to. In other words, the LCM is 6. So we are going to convert this 2 to 6 and 3 to 6, right? So if you are going to convert this 2 to 6 here, the first equation, what do we multiply by?
3.
Very good, 3, right? So remember what I told you. Golden rule, always when you make one change to one side in an equation, if you multiply this side by 3, the other side also going to multiply by 3 to maintain the equal sign. Okay, so that the whole third equation, I'm going to multiply by 3. Okay, so then 3 into 3y, each term multiply by 3. 3 into 2x plus is equal to 3 into 144. Okay, so 9y plus 6x is equal to, we'll quickly multiply 144.
432.
12, 1, 12, 13, 1, yes, 432. Right, now we'll name this our third, fourth, the next equation. Let's name it the fifth equation. Okay, right. So now we have converted the third to the fifth one. Now no longer we need the third equation. Right, fifth equation is enough to get our answer. Now the same thing, we have to convert this 3 to 6. So then you have to multiply this 3 by 2. So the whole equation, so the whole fourth equation, we are going to multiply by 2 here. Okay, so then 2 into 4y plus 2 into 3x is equal to 2 into 200. Okay, so then here 2 into 4y is 8y, 2 into 3x is 6x, and 2 into 200, that is 400. Let's name it our sixth equation. Now we converted the third and the fourth to 5 and 6 equation here. Right, now what you see? You can see in both the equations you have 6x and 6x. Now we are going to use this equation and remove x here, and we get a simple equation with only y. Okay, now I'll give you a choice. To remove x here, we can subtract 5 minus 6 and 6 minus 5. Both will give you correct answers. Both will give you your final answer be correct. But tell me, always you go for the best choice. Now here also, we can remove y first. Instead of removing x here, we can remove y. But we went for x to make it easier. Likewise, we can do 5 minus 6. That also will remove x. We can subtract 6 minus 5. That also will remove x here. But what is the best choice? Anyone? 5 minus 6. Why?
5
Why do you say 5 minus 6?
Get positive answer.
5 bigger number.
So both will give positive answers. Trust me, if you do both the ways, your final y will be the same answer. But why do we go for 5 minus 6?
Subtract a bigger number from a smaller number is easier.
Okay, one thing, your idea, bigger number minus small number on the one side. But what is the main thing? Yes, always keep the unknown term positive, right? The idea is now, when you subtract here, your x is gone. What will remain? Your y will remain. So always keep the y positive. That's the whole idea. Okay, to keep the y positive, check the y. See here, in the fifth equation, you have 9y. Sixth equation, you have 8y. So 5 minus 6, 9 minus 8, you will have a positive y. So the best thing is 5 minus 6 here. Okay. So then on your fifth equation, on one side you have 9y plus 6x minus left hand minus left hand, that is equal to right hand minus right hand. Okay. So left hand 9y plus 6x minus left hand here, always whenever you have a subtraction, follow up with the bracket. Whatever the equation, don't ever forget that. Okay. Many of you go wrong in that because you don't put a bracket. Okay. So what do? You put minus here 8y plus 6x. No, this is wrong. This minus is not only for 8y, minus is for the whole thing here. Okay. That is equal to 432 minus 400. Now open the bracket here, 9y plus 6x minus into 8y minus 8y minus into 6x minus 6x, that is equal to 32. Plus and minus will go off, 6 minus 6 is 0, 9 minus 8, that is y, y is equal to 32. What was y? Y was the number of boys. Okay, right. Now we need to find the number of girls. Now what do? Now no longer, now you know the value of one unknown term. Now in this equation, any equation now you take, is it a simultaneous equation any longer? Yes, now you know the value of one unknown term. Now, is this a simultaneous equation? No, now this became a simple equation, right? Before the two unknown terms, now you know the value of one unknown term. Then what can you do to find the simple equation? You just need one more equation. You can choose any of this, and what you can do, substitute the value of y here to find the value of x. So I'll substitute y to the third equation. Any equation you can take, because all of them, both left and right, are equal. You should get the same answer for x. Okay. So substitute y to the third equation, 3y. See here, 3y, you know the value of y, that is 32, plus 2x is equal to 144. 3 into 32, that is 96, plus 2x is equal to 144. Now here you can see it's a simple equation. Take the 96 here, becomes minus 96, 144 minus 96. Yes, how much is that? 148. 2x is equal to 48. Divide both sides by 2 here. X is equal to 24. So x is the number of girls. So there are 24 girls and 32 boys in this class. Is it clear, guys? Did you get the idea? Yes. Simultaneous equation, what do you think of? First thing you think of equation, right? Always equation. The first thing that should come to your mind, I have to build it. Okay, so think left and right. How do I make the left and right equal? Once you build a simultaneous, a pair, then what do? You have to think of removing one term. Convert, use both the simultaneous equation and convert this simultaneous equation to a simple equation. Right? So we use 3, see here, 5 and 6, converted the simultaneous equation to a simple equation with only one unknown term. Right? After you do that, you get the value of one unknown term. Then any longer, this is not a simultaneous. Why? Because we have found the value of one term, substitute it, get the value of the other unknown term. Any doubt here that you guys want to ask me? Or we can move on. Yes? Now, always a simultaneous equation question, the last part is regarding an inequality, right? So equation, you know, left and right are equal. Inequality, left and right are not equal. Simple as that. Okay. So we use 4 symbols: greater than, less than, greater than or equal to, less than or equal to. We'll see the last Roman number 3 there. The sewing cost for m number of blouses is 750. So there are m number. It can be 3 blouses, 4 blouses, whatever. Right. So for m number of blouses, if the sewing cost was 750, just a question before we move forward. For one blouse, how much is the sewing cost? Anyone? See, if I give you the other way around, for 3 blouses, the sewing cost is 750. What is the cost for one blouse? What would you say? Yes, what will be your answer?
750 divided by 3.
Divide by 3.
Divide by 3. Sorry, 750 divided by 3. Same thing here. Instead of giving 3, what did they give? They gave you m. So 750 divided by m will give you the cost of one blouse. Okay, we'll move on. And the sewing cost, now whenever you deal with unknown terms, give it a value, make it alive, and then you think of the example. Then it's easier to process. Now you saw there, when the cost of sewing cost of m number of blouses is given as 750, and I asked you what is the cost of one blouse, you guys were thinking, right? Didn't know how to get the answer. But when I told there are 3 blouses, the cost is 750, quickly you reply, how much is the cost of one blouse? So likewise, if you are confused, wherever it is, if I'm talking about equations, unknown terms, give the unknown term a value and think, okay, now you'll think better. Now then, instead of the value, if the unknown term was there, how will you change that equation? Okay, so here for one blouse, 750 divided by m. Okay, and the cost of 2m, the sewing cost for 2m number of skirt is equal to 1125. Okay, so then again, what is the sewing cost for one skirt? Yes, there are 2m number of skirts, that the cost is equal to 1125. What will be
Divide by 2.
Very good. So 1125 divided by 2m. That will be the swing cost for one skirt. Now you know the swing cost for one blouse. You know the swing cost for one skirt. Now what are they asking? Write down an expression for the swing cost of one girl's uniform in terms of m and simplify it. Okay. So one blouse, the swing cost is 750 over m. Now you know a girl's dress is made up of a blouse and a skirt. So for one blouse, the swing cost is 750 over m. And for one skirt, the swing cost is 1125 over 2m. This will be the swing cost for one girl's uniform. Simplify it. How do you simplify it? You have a fraction with what? Unknown terms. One is m, the other is 2m. How do you add this? Yes? Make the
Denominator equal.
you make the denominator equal. If you have m here, 2m, what can you do? What is the LCM here? M and 2m. Yes?
2m.
2m is the LCM. So what do? You convert this to 2m, you multiply by 2, both the numerator and denominator. Now you have 1500 divided by 2m plus 1125 divided by 2m. Now both are the same. What can you do? You can add the numerator 2525. 2525 divided by 2m. Is that clear, everyone? Correct, right? 2000, not 500, sorry, 2600. Right? My bad. Is that clear? Any doubt here? No, right? Can you move on there? Bit late on the schedule because it's my mistake, not your guys, okay? Right. Next, move to 2019 past paper. Right. We'll see how we can relate the same way of thinking in the next question also. Right. Now there are 5 boys and 4 girls in a group of dancers. In a certain performance, all the boys wore costumes of the same price and all the girls too wore costumes of the same price. Okay. So then the price of 2 boys' costume was 1000 rupees more than price of 3 girls' costume. Okay. So then the cost of costumes of all the children in the group was 14,000. Now you can think of, right, 2 such equations that were there. One equation was, see there, the price of 2 boys' costume was 1000 rupees more than the price of 3 girls' costume. That is one equation you can think of. Price of 2 boys' costume was 1000 rupees more than 3 girls' costume. Okay, so 3 girls' costume plus 1000 is equal to the costumes of 2 boys. That's one equation right there. And price of all the boys, costumes of boys, plus price of all the costumes of girls, they have given to the total price, that is 14,000. 2 equations built, right? So that's how you think. Okay, so then we'll write it down here. I feel bad. There are many students who message saying that they couldn't join. Like, one thing, to be honest, I didn't think you guys, everyone will join, right? I didn't think, I knew the limit was 100, but I never thought you guys will join because one thing, it's a night class, right? So, but later, even from last class, I understood. Now, normally when I have my theory class or whatever the paid class, you guys easily skip the class, right? Saying whatever the reason that you want. But last week when I had last week I just had a test run, like just test run. I didn't know this will work, that night class. Everyone who paid, it was a free class also, but everyone could join, right? It was a free class, but I didn't advertise or anything. Everyone who paid, they still came for the night class, especially the ones who didn't come even for the morning, this normal class time. Then I understood, okay, these people, they don't sleep at night. Like you sleep at 2 o'clock, 3 o'clock. I don't know what time you guys sleep, right? So I prepared myself to stay awake from 10 to 12 because I usually sleep by 10. Okay. So then, we are 9 hours, right? Okay, fine. Anyways, Batman, good. Right? At least I have found your guys' strength and I hope I'm using it properly, right? So I think night class is good, right? So you guys will stay awake and join. And I feel like you guys are more awake at night than in the normal class hours in the morning time. Okay, I know usually keep in weekends, right? So even in the weekends, you guys in the morning time, you guys don't join, but night time, and you guys are more than ready to join the class. So it's good. So I'm thinking late also, even to make the paid classes at what 12 to 1 or maybe 11 to 1. We'll see. So it's actually a thought process, right? Okay, so then where are we? Why did I forgot what I was doing? Yes, Sauda, you have anything to say? Yeah, physical students are okay. They attend the class. I'm talking about online, right? Yeah, I think I came to take questions. Okay, anyways, I forgot what I was going to do.
2019.
Okay, this equation then. So you have anything to tell? I can't hear you, Sauda. Okay, I think it's a mistake. Anyways, so then they have given you, right? We are going to build the equation. So one equation is, I'll just give you a sketch here, then we'll build it, right? So costume of 3 girls, right? Oh, sorry, costume of 2 boys, right? Is 1,000 rupees more than the price of costume of 3 girls. Okay, so that means costume of 2 boys is equal to the costume of 3 girls plus 1,000. 1,000 rupees more, right? Guys, one thing you have to understand these words: more, less, time, thrice, twice. These are simple words, right? More or less. Now let's say I have 100 rupees. Another person has 50 rupees more than me. When you guys see a word more, you just multiply. I don't know why that thought process come, right? So when a person, let's say I have 100 rupees, another person has 50 rupees more than me, that means the other person has 150 rupees. You add the 50 to this 100. So 1,000 rupees more than the costume of 3 girls. So 3 girls, you have 1,000 rupees more than that plus 1,000. That is equal to the costume of 2 boys. Okay. Next, they have given you costume of all the people, 5 boys and 4 girls. That is equal to 14,000. Right. So 5 girls plus 4 boys, the costume is equal to 14,000. These are the 2 equations that you can build here, right? Now we'll see, take the price of boys costume as X and the price of girls costume as Y and construct a pair, 2 simultaneous equation and represent the above information. So costume of boys is X1, price of 1 costume of boys X, price of 1. Okay, this place is not built by me. Okay, anyways, one person is commenting the vase is nice. Okay, so then the price of 1 boy's costume is X and the price of 1 girl's costume is Y. Okay, so 1 boy's costume X. So if you have 2 boys, what do you do to find the price of the costume of 2 boys? For 1 boy X, for 2 boys 2X, for 3 boys 3X. That means price of 1 costume into the number of boys. Okay, so likewise, 1 costume here, that's why I put up boys here, 2 costume. So 2X is equal to, we are building the first one, 3Y plus 1,000. That is your first equation. Right? Now, guys, before you mark the equation, have a standard in the simultaneous equation. Now here, this is not a compulsory thing, but this is what I follow. Right? Always keep the unknown terms to one side. Okay? Your X and Y or whatever, keep it to one side. And the numbers or the values to the other side. Okay, so I'll take the 3y here. Before I mark the equation, I take the 3y here. Now I have 2x minus 3y, that is equal to 1,000. Now I'll mark this the first equation. Yes?
Is it 5 girls or 4 boys?
Sorry?
Is it 5 girls or 4 girls?
5 boys and 4 girls. The other way around, no? 5 boys and 4 girls. I'm sorry. Thank you for letting me know. 5 boys, 4 girls. Okay. So then next one, right? Now here we can build the same thing. Boys is X, girls is Y. So 5X plus 4Y, that is equal to 14,000. Okay, that is our second equation here, right? So we have built two simultaneous equations. Now the whole thing is to solve it. Okay, so solving it means, what is it? We use both the simultaneous equation. We now want to make a simple equation. Creating a simple equation means removing one unknown term. So here we have to decide to remove y or to remove x here. How do you think that? How do you decide to remove x or y? Think how to make both of them equal. To remove it, it should be definitely equal, right? Then you can subtract and remove it. Okay. Now 3 and 4, what is the least common multiple? The common number you can reach, that is your LCM. That is 3 and 4. The LCM is what?
12,
12. 2 and 5, what is LCM?
10.
10. Now here it's almost the same, right? 10 and 12 multiplication won't differ much. So you can choose whatever you want. You either remove x or remove y. Now here I have a bit of a favoration to remove x rather than y. I'll tell you why. Okay. Now here y, one is negative, the other is positive. What does that mean? Simply, if you convert both of them to 12, right? Simply if you add them, opposite signs, right? One is minus, one is plus. If you add them, it will get cancelled off. Right? Always prefer addition than subtraction. Right? Now, when you do a lot of questions, you can develop this little by little by little. Now, all of a sudden, if I tell you all this information dump into your head, it will be difficult. So first you have to understand simple idea, simultaneous. You have to remove the one unknown term. Then little by little I told you, okay, if you are removing, how to choose the best one. First thing you think of the LCM. Take the easiest one to multiply. Now here 10 and 12, almost both are the same. Now what is the next thing you think of? Look at their signs. Always try to choose one with the opposite sign. Why? You can easily add them. Opposite signs mean if both the coefficients are same, both are 12 and 12, if you add them, it will get cancelled off. If the signs are the same, let's say here, both are negative here, or both are positive, signs are same, signs are different. So if the signs are same, both are negative or both are positive, to remove it, always you have to subtract. Okay, that's how you think. If the signs are same, to remove it, subtract. If the signs are opposite, to remove it, you have to add them. Okay, always prefer addition over subtraction. Okay, so then here, if you are at a choice where you have to remove x or y, now both the coefficient almost you have to multiply by the same number. Multiplication doesn't make much of an effect. Now here I will choose y here because the signs are opposite. I can easily add them and remove y. Okay. So then what I'll do, I'll think of removing y. That is I multiply the first equation. Now 3 and 4 convert it to 12. So to convert 3 to 12, I multiply by 4 here. Okay. So then first equation I multiply by 4. Each term multiply by 4. 4 into 2x minus 3y into 4, that is equal to 4 into 1000. 4 into 2x, 8x minus 12y, that is equal to 4000. Now I've converted the first equation to the third equation. No longer I need the first one. 1 is converted to 3. You deal with 3 now. Okay. Now the second equation, to convert this to 12, I multiply by 3. 3 into 5x plus 3 into 4y, that is equal to 3 into 14,000. So then 3 into 5x, 15x, 3 into 4y, 12y, 3 into 14,000, 42,000. That's my fourth equation. Now you can see here, one has minus 12y, the other has plus 12y. Both are same coefficient, 12 and 12, opposite sign. To remove it, what do you do? Simply you add them. Okay. So then 3 plus 4 will remove y. Okay. So then third one you have 8x minus 12y plus. Fourth one you have 15x plus 12y. What do you have here? 4,000 plus 42,000. So then minus 12y plus 12y gone. 18 plus 15, that is 23. 46,000. Divide both sides by 23 here. X is equal to 46 divided by 23 is 2. X is equal to 2,000 rupees. What was X? X was the price of one boy's costume. Now we need to find the price of one girl's costume. Easiest equation is your first equation here, right? That is the easiest one. So substitute X to the first equation to find the value. Now no longer this is simultaneous. Before it was simultaneous. Now you know the value of one unknown term. Now it's a simple equation. Okay. So 2 into X. 2 into X here. Right? We have 2 into X. Right? X is 2000. So 2 into 2000 minus 3y is equal to 4000. Okay. Now how do you find 3y? Always keep the unknown term positive. So what do? Take the 3y to this side to make it positive. At the same time, take the 4000 to this side. Switch. Okay. So then 2 into 2000, that is 4000 plus, yes. Did we miss something? No, right? Sorry. 2x minus 3y is equal to 1000. I'm sorry. Should be 1000, right? Right? So 4000, 1000 comes here, it becomes plus 1000 comes here, it becomes minus 1000. That is equal to 3y. 4000 minus 1000 is 3000. So 3y is equal to 3000. Divide both sides by 3. So then you have y is equal to 1000 rupees. So cost of one girl is 1000. Cost of one boy's costume is equal to 2000. Any doubt here, guys?
No.
Yes, we are done with room number 1 and 2. Okay, right. B part, simplify. 5x over x squared minus 1. Yes, Aisha.
So why it's getting multiplied by 2?
Why did we multiply by 2?
Yeah.
Which part?
Finding x.
Finding x. Why did we multiply by 2? Where is it? Where did we multiply by 2? Here.
No, below that.
Below that. No. We substitute to this equation. Now, the first equation here. The first equation, what do you have? 2x minus 3y is equal to 1000. This is your first equation. So then 2 into 2x means 2 into x, right? So 2 into x here. X value now we know 2000 minus 3y, that is equal to 1000. So then we swap here 4000 minus 1000 is equal to 3y. Now this is 3000 here. That is equal to 3y. Divide both by 3. Y is equal to 1000. Okay.
Yes, sir.
I understood. We multiply by 2. It's part of the equation. Okay. Clear?
Yes, it's clear.
Yeah, good. Okay. Last, the B part, simplify. They have given you an algebraic fraction, right? So then I'll quickly go through that. So what they have given you. So 5x over x squared minus 1, right? Minus 4 over x plus 1. Right. Now here, in a fraction, to solve a fraction, both the denominators should be the same. That is, you have to find the LCM. Right. Can someone tell me, this is definitely a quadratic expression. X squared, now wherever expression, the unknown term has a square, you call it a quadratic expression. Now this is a quadratic expression. Now this is special type of quadratic expression. Can someone tell me what is the speciality? What do you call this? Yes? Anyone?
Difference of
Very good. Difference of what? Complete. Yes, Asifa, difference of what?
difference of two squares.
Very good. Difference of two squares. Okay. So this is special type of trinomial quadratic expression. Trinomial means 3. Quadratic, the unknown term has a square expression. But here we don't have 3 terms. The middle term is 0. Right. So we don't show the middle term here. Right. So what we have is x squared minus 1. Now we have to find that. Now, first of all, now you correctly told the denominators are different, we have to find the LCM. Before finding the LCM, here they have given you a quadratic expression. First, we have to find the factors. If you know the factors, or you can find the LCM. To find the factors here, these are trinomial quadratic expression, but a special type. Trinomial, you know, there should be 3 terms, but here you have only 2 terms, right? So this is a special type called difference of 2 squares. You understand by the term itself. 2 squares means what? It should have 2 square parts. One, we can write the 1 as 1 square. 1 square is also 1. So normal 1 we can write as 1 square. You can see here you have 2 squares here between 2 numbers. There is difference means subtraction, right? Now, how do you know when you look at the expression? How do you know this expression is a difference of 2 squares, right? I told you 4 things before, right? So what are the 4 things I've told you? One thing, definitely it should be a quadratic equation. That is, the unknown term should have a square. That is the first thing you look at. The second thing, you have only 2 terms. Usually, ideal way, trinomial quadratic expression have 3 terms, right? You have only 2 terms. Between those 2 terms, you have a subtraction, you have a minus sign. Lastly, all of the terms can be written as a square. That is, for example, let's say you have x squared minus 4. Looking at this, I can tell directly this is a difference of 2 square. Why? First thing, the unknown term has a square. You have 2 terms. Between the 2 terms, you have a subtraction. And finally, both the terms can be written as a square. 4, I can write it as 2 square. So x square minus 2 square. So yes, this is a difference of 2 square. Let's say, for example, another question. 4x squared minus 9. The unknown term has a square. You have 2 terms. Between 2 terms, you have a subtraction sign. Each term, you should be able to write as a square. So 2 square, x square minus 3 square. So expressions like this are called difference of 2 squares. You have 2 squares, you are finding the difference. Clear? Okay. Now, how do you find the factors of these expressions? Now, easily, now trinomial quadratic expressions, you have to go through some steps. Okay, I'm not going to go through that now, right? But this difference of 2 squares, you can easily find the factors, right? Now, usually trinomial quadratic expression, you have 2 factors, right? So here also you have 2 factors. One factor is the positive and one factor is the negative. What does that mean? So that is, one is x plus 1, the other factor that is x minus 1. So the factors of x squared minus 1 is equal to x plus 1, x minus 1 into. If you multiply this, you'll get this answer back again. Okay. Now we can write 5x divided by x plus 1 into x minus 1 minus 4 over x plus 1. Now you can see the denominators are different. Now we can find the LCM. You can see in this denominator, you have x plus 1 into x minus 1. Here you have only x plus 1. What can we do to make the denominators the same?
Multiply by x minus 1.
Very good. You multiply this by x minus 1. And you know, if you make a change to the denominator, you have to do the same change. It's just like an equation. In equation, both left and right, whatever you do to left side, you have to do the same thing to the right side. In the fraction, whatever you do to the denominator, do the same thing to the numerator. Why? To make it equivalent fraction. They are to keep the equal sign here to make sure you don't change the fraction value. That is called equivalent fraction. Okay. So now we can solve it. 5x divided by x plus 1 into x minus 1. Right? Now here there is a steps to get through LCM. I won't go through all of that. Like I said, I told you before starting the class in the channel, this is not a theory class. So I won't be teaching the theory from the beginning. Okay. So then here x plus 1 into x minus 1. All right. So now you can see the denominators are equal. Now you can add the numerator. No, sorry, subtract. You can subtract the numerator. Okay. So then here you can open the bracket 4 into x, 4 into minus 1, right? So 5x divided by, now both the denominators are the same. So I can write it as 1, x plus 1, x minus 1. So here you have on this side you have 5x minus, now what did I tell you? Always minus, follow up with the bracket. Don't ever forget that, right? So minus, open a bracket here, 4 into x is 4x, 4 into minus 1 minus 4. Now we can write this. Now again you have to open this bracket here. Minus into 4x, minus into minus 4. So 5x minus into 4x is minus 4x, minus into minus is plus 4. Divide by x plus 1 into x minus 4. 5x minus 4x, that is equal to x. So now your final answer, x plus 4 divided by x plus 1 into x minus 1. Okay, that will be your final answer. These are the steps you have to go through, right? You have to show how you got the factors. After you got the factors, getting the same denominator, solving it, getting the final answer. Those are the steps that you will get marks for. Okay, right, quickly we'll go to the next one. 2020. Right. Okay. Now this should be easy. We have done 2, right? 2020 should be fine. Right. A hall is decorated with white flowers and red flowers. 3 times the number of white flowers used for this is 100 more than the number of red flowers used. Okay. So now you can understand 3 times the number of white flowers. Now look, go to Roman number 1 quickly. Check white flower, what is the unknown term? Red flower, what is the unknown term? White flower is X, red flower is Y. Okay. So erase this. So only for this class, I'll be giving the recording. The whole point of these sessions are for you to join live. Okay. So only for this class for the students, because there's some students they couldn't join. I feel bad. I feel really bad, right? So then I couldn't help them also. So I'll send the recording to the channel, right? But from next class onwards, there'll be no recording because everyone will have opportunity to join the class, right? So please join the class. No recording will be provided. Okay. Okay. So then, because I know because you don't have any other class during this time also, so you can't say any other excuse. No transport issue. Online class. Okay, so everyone should be able to join the class. Okay, a hall is decorated with white flowers and red flowers. Okay, so they have given you X is the white flower, Y is the red flower. X is white, Y is red. So now we'll read the statement again. 3 times the number of white flowers. White flower is X. 3 times the number of white flower is 3X. Okay. So 3X used for this is 100 more than the number of red flowers used. So 3 times the number of white flowers is equal to what? 100 more than the number of red flowers. So 3x is equal to, is it equal to the red flowers? No. 100 more than the red flowers. So 100 more means, I told you, more is addition. Okay. So red flowers is white. 3x, 3 times the number of white flowers is equal to what? 100 more than the number of red flowers. So y plus 100. That is your equation number 1. Each white flower is 12 rupees and each red flower is 11 rupees. Okay. The cost of the white lotus flowers used for the decoration is 1,600. So the total cost is 1,600 and they have given you 1 white flower is 12 rupees. Now you have X number of white flowers. Can someone tell me what is the total cost of white flowers? If 1 flower is 12, you have X number of white flowers. So what is the total cost of white flowers?
12x.
12x.
12x. Very good. Right. So if 1 red flower is 11 rupees, what is the total cost of all the red flowers?
11y.
Very good. So then you have the total white cost, the total red cost, and the total cost. So what can you do? Build an equation there. Now here I told you always keep the unknown terms to one side. We'll take the y here. 3x minus y is equal to 100. We'll name it first equation. And the other one, 12x plus 11y. Cost of white flowers plus cost of red flowers will give you the total cost. That is 1,600. Okay. Now see here. We'll see which one is easy to remove. That is the next thing. Now we have to solve this, right? That's what they're saying, right? Solve it, right? To solve it, convert the simultaneous equation to a simple equation. Okay. So then here you have 3x, 12x. Tell me, what do you do here? 3x to 12x. What is the LCM? If you need to remove x here, both the coefficients should be the same. 3 and 12, what is LCM?
12.
12 is the LCM. Then this is already 12. This 3 to convert to 12, you have to only multiply by 4. So only one equation you have to multiply. That is 1 plus point. Okay, we'll see the y here. To remove y, what do you have to do? Yes, here 11, here 1. What is LCM? Obviously 11. You have to convert this y to 11. You have to multiply this equation by 11. So what do you think is easy? Converting to 12 is easy or converting to 11 is easy?
12 is easy.
Okay, one person is saying converting to 12 is easy. But honestly, in this point, I would prefer the 11y. Why is that? I told you the next step that you see. See here y has opposite signs. So easily, always go for addition. Okay. So always try your best to minimize the errors that you can do. Subtraction brings problems, right? So always go for addition, but always think of the other side also. Now, if this now here, let's say for example, if this was 4, now then what? Now you have to multiply both the equations to get 12. Then at that point, definitely I'll prefer this y here to remove y. Now, because this is 12, right? I need to already multiply one equation. Sorry, that example is wrong. Let's say. Sorry. Let's say this was 2y. Sorry, forget about what I said before. Let's say this was 2y. Now, 2 and 11, the LCM is 22. That means this equation also have to multiply by 11. This equation have to multiply by 2. So at that point, I will definitely prefer this x here to remove x. Why? Because I have to multiply only one equation. Understood? So at that point, I would prefer to remove x here. But here, to remove any x or y, both the times, I have to multiply only one equation. Then go for the next one. Look at the sign. If the sign is opposite, you have to remove it. You just have to add it. So addition is easier. So at this point, I would prefer to remove y here rather than x. Although x, you just have to multiply by a smaller number. Okay. So then here what I'll do, first equation, I'll multiply by 11 because I'm removing y here. So 11 into 33x minus y into 11, that is equal to 11 into 100. So 33x minus 11y is equal to 1100. I'll mark it the fourth equation. Now simply, I've converted the third equation. I've converted the first equation to the third one, right? So I don't need the first equation now. 2 and 3. Look at 2 and 3. This plus 11y minus 11y. To get rid of the y here, I just have to add it. So second equation plus third equation. So 12x plus 11y plus 33x minus 11y is equal to 1600 plus 1100. So here you have 2700, right? So plus 11y minus 11y cancel off. 12 plus 33, that is 45x. I'll go up there. Divide both sides by 45. X is equal to 2700 divided by 45. Now 27 and 45, you can divide by 9. To divide by 9, 3 here. Divide by 9, 5. 300 divided by 5 is 60. What is X? The number of white flowers. So that is what? Number of white flowers is 60. Now what you can do, substitute X to equation number 1. So then 3x minus y is equal to 100. That is your equation number 1. So 3x, 3 into 60 minus y is equal to 100. So what do? Make the y positive, unknown term positive, bring the 100 to this side. 3 into 60, that is 180. 100 plus 100 becomes minus 100. That is equal to y here. 80 is equal to y. That is the number of red flowers. So y is equal to 80. Is that clear, everyone? Any doubt there? If you have any doubt, please do ask. Right? Now, Roman number 1 and 2 we have done. Roman number 3, show that the difference between the amount spent on red lotus flowers and the amount spent on the white lotus flowers is more than 150. Now we have to find the amount spent on white and red separately. Right? On white flowers, the cost is 12 rupees, but we have only 60 flowers. So 12 into 60, that will be rupees 720. For red flowers, one is 11 rupees, 11 into 80. How much is that? Rupees 808. So now to find the difference, right? Red minus white is equal to 880 minus 720. How much is that? 160. So then what can you say? Yes, 160 is greater than 150. Simple as that. Okay. We have to show the difference between the amount spent on red and white is more than 150. Done. Okay. B part. Regarding formula. Make H the subject of the following formula. Right. So U is equal to square root of 2GH. Right. So U is equal to square root of 2GH. What do you have to do? Make H the formula. Right. So one by one, we are going to slowly reverse it. H is the one we need, right? So first thing we have to remove the square root. Without removing the square root, you can't find the subject the H there. Now always think of the opposite mathematical calculation. Now this formula is the basic to solve any equation. Now when you send the positive, that side becomes negative, part of formula. When you take the division to other side becomes multiplication, part of formula. What is the opposite mathematical operation for square root? Anyone?
Square.
You know, addition, opposite is subtraction. Multiplication, opposite is division. So then, what is the opposite of square root?
Square.
Square, right?
Yes.
So squaring something, x square, right? Opposite, not equal. Opposite of square root of x is x square. Okay. So likewise, now you have studied log also. Opposite of log is anti-log. Okay. So likewise, any mathematical operation, remember, there is an opposite mathematical operation to it. So then here, to remove the square root, that means what we have to do? Do the opposite mathematical operation. So if you square this, what will happen? Square and square root will get cancelled off, right? You know, in an equation, if you do one change to one side, do the same change to the other side. If you square this, you are going to square the other side also. So now you have u squared is equal to, now the square root is removed, that is equal to 2gh. Okay, now we have to find the value of h, right? We have to remove the 2g. You can see here, 2g is multiplied. Opposite of multiplication, division. So you divide by 2g here. To remove the 2g, do the same thing to the other side. 2g is cancelled. H is equal to u squared divided by 2g. Okay. So to subject, not only in this, any equation, here also you are subjecting. Here we have 45x is equal to 2700. You are subjecting x. Subjecting means you are making that term the main character. Okay. Before the main character was u, now you are making the main character h. You are keeping that term on one side, taking all the other terms to the other side. That is the idea of subjecting. Here, to find the value of x here, you have to subject x. That means take the 45 to the other side of the equation. Got that, everyone? Any doubt there? All right. Can you move on? The last two questions regarding quadratic expression. Sorry, quadratic equation. No doubt, right?
Okay.
Okay. All right. Next one. Now, quadratic form equation, right? Again, Now remember, quadratic equation is pure calculation. Now what you're going to learn now is pure calculation. Yes, you need some logic behind it, definitely. But then at the end of the day, we always think of doing the question. Right? So when you are doing the question here, you can see it's pure, not now. When you see Venn diagram, we've done Venn diagram questions. No calculation at all. Just very simple addition, subtraction here and there. It's all about understanding. But here also you have a bit of understanding, but majority, the chunk of it is calculation. That means what? You have to get good in simplification, right? If you're bad at simplification, multiplying, dividing, addition, subtraction, square root, squaring, then this is a bit tough for you, right? So the advice is not to skip the question. I would never tell anyone to skip a question. Skipping a question should not be, how do you say, decided before facing the exam. Once you take the paper, when you go through all the questions, that is the moment you decide what question to skip, right? Don't ever plan your skipping part. Trust me, it will go wrong, right? I'm not wishing that you should go wrong, but I'm saying there's a higher chance for it to go wrong because the question that you think easy, you might not be able to do that in the exam. They might make that question difficult, right? You can never know. So prepare for all the questions and go to the exam. There you decide what to skip. You have an upper hand. You know all the question. You will choose the best for you. The one that is no. Yes. What is it about? No, right? Okay. So then this question is a bit heavy on the calculation side. Okay. And you have to memorize the formula, the quadratic formula. Definitely without the quadratic formula, you can't do. Okay. And some of you guys might tell, sir, what about completing the square? I don't advise you to complete the square. Okay, there's another method called completing the square. I don't advise it, right? Memorize the formula, the quadratic formula. You will never go wrong, right? Completing the square, higher chance of you making mistakes, right? So always stick with the formula. Formula, you will never go wrong. Okay, right. Now you have, see there, now here also it's a equation. So first and foremost, you think how to make an equation. That should be the thought process, right? That should be the first thing in your map. Make an equation. Next, you're going to convert that equation to a quadratic equation. I'll tell you now in a while what is a quadratic equation. Then what do? You think of solving the quadratic equation. After you solve the quadratic equation, you'll get the value of an unknown term. Then they'll ask you one more simple question. Then you, with that unknown term, after you find the value of x, then you can find answer for the last question they ask for. Okay, we'll see there. Now, a lamina consisting of a semicircle A of radius x and a sector B with an angle at the center 60 degrees. Now, one more thing in this question, you need to know the equation for areas because I think all the questions, if you go through all the 10 past papers and 10 years of past paper, they related to area of the shapes, that is circles, triangles, rectangle, trapezium, not much of parallelogram. I'm not saying parallelograms. Anyways, so these are the shapes of areas that you need. They're not going to give you the equation for area. It's easy, okay? It's not difficult. Now, you know, rectangle and squares, the area is length into breadth. For triangles, half into base into height. For trapezium, half into addition of the parallel sides into the perpendicular height. For circles, pi r squared. If you have a sector, simply what you do? Multiply the pi r squared by theta over 360. No, they will never tell you. Trust me, they will never, ever tell you. Use the, show me one past paper where they tell you to use the completing square method, only completing square. Okay, only completing square to do the question. They will never advise, they will never instruct you like that. Okay, because the standard way, even in, I don't know, even in London syllabus, the standard equation is this, the quadratic formula. Okay, and stick to it, guys. It's so much easy when you memorize something rather than working things out. Okay, I know it's a wrong advice to give. Always you have to think logically. Yes, understood, but at the same time you have to get marks. Right? Our whole idea is for us to get marks. Now the question is 2019 fourth essay. Like that's the question we are doing. The whole idea is to get marks. So we try our best to go through the easiest route, right? That is a quadratic formula. Okay. So then You have to know the equation for areas. That's the advice I'm going to give you right here. Apart from knowing how to solve quadratic equations, yes, that is one thing. Here they test you the knowledge of areas as well. Just to know the equation for areas. Okay, you must know that. So you have a semicircle of radius x and a sector B with an angle at the center 60 degrees, which is concentric with the semicircle, is shown in the figure. If the area of A and area of B is equal, that's the point there, right? So you have the point of equation. Area of A, write it down. Okay, area of A is equal to area of B. Because most of you guys, you don't know where to start the question. That's your problem, right? So area of A is equal to area of B. That's why you start, right? So area of A is a semicircle. Area of B is a sector of a circle. So you know the equation, right? Pi r squared into theta over 360. That is the equation for area of a sector. Okay, right. So then they are telling you build a quadratic equation. I'll tell you what is a quadratic equation and show with reason that x can take exactly one value and not both values, right? We'll see why is that. So by using 1.73 for the value of root 3, find the approximate value for the radius of B to the first decimal place. Now to find the radius of B, can someone tell me what is the radius of B in terms of x? Yes?
X plus
Look at
4.
that. Very good. X plus 4. Can you see there? Radius, if you have this semicircle here, right? So they have given you this is center of this circle and this circle. Both the circle, the center is this. Radius has given as x here. If this is x, you know all the radiuses are equal. This also will be equal to x. They have given you this is 4 meters or centimeters. They have not given you just 4. Okay. So radius of this B here is from the center to the circle. So that is x plus 4. That is one thing you have to notice. Okay. So radius of the circle B or the sector B is x plus 4. Now we know area of A is equal to area of B. That's where you start the equation. Now you know area of a sector for a full circle pi r squared. Whenever you have a portion of a circle, you multiply this pi r squared by theta over 360. Okay? All right. So then we know area of A is equal to area of B. So pi r squared into theta over 360 is equal to, again we can write pi r squared into theta over 360. Now mind you, you might think both are not the same. Radius is different, angle is different. So it's going to differ. Okay. Now what is equal on both the sides? Can someone tell me? What are the values or terms, whatever it is, what is equal on left and right?
Pi.
Pi r square.
Pi is equal. Anything else?
360.
360 is equal. Now one thing I should tell you. See here. If you take the same side of this, I told you for the last class, paper class students also. If you take the same side of the equation, that is, let's say, I only consider the left hand side here, right? Then you can cross simplify, that is numerator and denominator, or on the same fraction also numerator and denominator. For example, let's say I have 2x into 3 over 4. That is equal to 5y into 6 over 8. Just for an example, okay? Now you can see here, on the left hand side, you can simplify 2 and 4 here. You can simplify, you can go ahead, right? But if you see on both the side of the equation, left and right, denominators, look at the denominators 4 and 8. You can simplify, divide both sides by 4. 3 and 6, you can simplify, both you can divide by 3. So what do you know here? If it's on the same side of the equation, you can simplify, cross simplify, always cross simplify, numerator and denominator. If it's across the equation, that is left and right, okay, you can simplify, but on the same level, numerator and numerator, denominator and denominator. Not cross simplify, not this and this. No, 3 and 6, 4 and 8. So across the equation, you simplify at the same level, across the equation, right? Listen carefully. Across the equation, you simplify at the same level. On the same side of the equation, if you look at only the left hand side, the simplifications of cross simplification. Okay, that will use that knowledge here. We can easily get rid of the pi here. Pi and pi is the same thing, cut it off. 360 and 360 is the same thing, cut it off. Don't cut off theta, only theta is different on both the sides. Okay. Now radius of A is given as x squared into, now theta is 180, right? 180. That is equal to what? R squared. Now what is the radius of B? We told is equal to x plus 4. So x plus 4 whole thing square. R is x plus 4, you have a square there, into what is theta? Theta is 60 degrees. Okay, now again 60 and 180, what can you do? You can again divide by 60. 60 divided by 60 is 1, 180 divided by 60 is 3. Now what do you have here? 3 into x squared, 3x squared, that is equal to x plus 4 whole thing squared. Now what is this, guys? What do you call this? Anyone? What do you call this? What type of expression? Now, one person is asking, can't we take out the square? Square is not a term to cut it off. Okay? It is a mathematical operation. It's like you're asking, both sides you are added, can't you cut the addition part? Doesn't work like that. Understood? So square is a mathematical operation. You can't cut off the mathematical operation, right? Yes. Tell me, what is this called? Anyone?
Square of binomial expression.
Very good. A square of a binomial expression. Binomial expression means two terms. X plus 4 is a binomial expression, right? Usually what you get? A product, multiplication of two binomial expressions. But here, both the binomial expressions are the same. X plus 4 is multiplied by another x plus 4. So then we can write it as a square of a binomial expression, right? Now here, a square of a binomial expression, completing square, if you find it easier, definitely they'll give marks for you. The same marks is provided as using the formula, right? But my advice, if you're good in completing the square, go for it. No one is stopping you, right? But my advice, let's say you're the same level, completing the square also, let's say, and doing the quadratic formula also, not very confident. Then go try doing more questions on quadratic formula and try getting good in that rather than completing the square. That's my advice, right? So then here, if it's a square of a binomial expression, how do we open the brackets? How do you expand it? Now you know there will be three terms. What is the first term, everyone?
X squared.
Square of the first term inside the bracket. So that is x square. What is your second term?
8x squared. Multiply both the
Now, x square, multiply both the terms inside the bracket. 4 into x, and then you multiply that with
2.
2. So 4 into x is 4x. Multiply that with 2. 8x, not 8x square. Okay, 8x. What is your third term?
16.
Square of the last term.
Square of the second term inside the bracket. So that is 4 square, that is 16. Okay. So any square of a binomial expression, this is how you open the bracket or expand the bracket. Okay. Three terms. First term is square of the first term inside the bracket. Second term is when you multiply both the terms inside the bracket and you multiply that with 2. Third term is when you square the second term inside the bracket. So that is equal to 3x squared. Now I should tell you what is a quadratic equation, right? So the general quadratic equation, we write it as general equation, right? Ax squared plus bx plus c is equal to 0, right? So this is your quadratic equation. So any equation where one side is 0 and you have a quadratic expression on the other side, you call that a quadratic equation. Okay. So quadratic expression on one side, on the other side it is equal to 0. That type of equation, you call it a quadratic equation. Now next we are going to apply the quadratic formula. For you to apply the quadratic formula, you need a quadratic equation. That means what should we do? We have to convert. Now you're at this point, right? You have to convert this to this quadratic type of equation. That means one side is 0, on the other side, you have all the other terms, right? That means either all of this you take it to this side, or the 3x squared you take it to the other side, because one side definitely there should be 0. Okay, my question, what do? Do you take all of them to this side or 3x squared to the other side?
Take
All of
back
take
to the other side.
So most of you
all
are
of
saying you take the 3x squared to other side. Any other opinion?
no, the other way.
All the other to
Right.
this
All
side.
of them to this side. And tell me the reason for it. Now, the people who told 3x squared take it to the other side. Why do you think that's the correct way? Any answer?
It's easier to make
Because
it
16 is already positive.
If you take 3x squared, what is it? It is easier. Yes?
Yeah.
Okay, fine. The ones who told you take all of them to this side, what is your answer? What is your reasoning?
To keep the unknown term positive.
What unknown term? I have two unknown terms. One is x, the other is x squared. So what do you focus on?
Extra.
Very good, right?
Extra.
So you guys, when you're making one side 0, remember, keep this in mind. Always keep the quadratic term. What is your quadratic term? I told you before also. The quadratic term is the square of the unknown term, x square here. Always keep the x square positive. Okay? So you have to focus on the x square here. Forget about this for a while. Just focus on the x square and think. If I take it to this side, will the final x square be positive? Or if I take this to this side, will the final x square be positive? Okay. If you take the x square here, you have 3x squared minus x squared, you will end up with 2x squared. Yes, then it is positive. But if you take it to this side, you have x squared on this side. Now here you have minus 3x squared, you will end up with minus 2x squared. So no, this is what you will stick with. You take the x squared to this side. Now, on the way, you can't just take the x squared. You take both of them also to this side to make one side 0, right? So always remember, when you're converting the equation, right, this equation that you built, when you're converting it to a quadratic equation, always keep the quadratic term, that is your x square, positive. Okay, so in this time, we are going to take all of them to this side. So 3x squared minus x squared minus plus 8x will become minus 8x plus 16 become minus 16, that is equal to 0. Is that clear, everyone? Understood?
Yes.
Yes, sir.
Okay, so I want you guys to learn few things. I know everything that I tell today. Personally, I know I'm going a bit fast. I understand that, right? But like I said, not a theory class, just a paper discussion session, right? So I can't go very slow. I have to go in the middle pace. I'm not going too fast also, right? But I'm going in the middle pace so that on both the ends, students on both the ends can catch up somewhat. Okay. So then you have to understand, you have to learn few things before every class that I do, every week that I do, learn few, especially simplification techniques like this, right? Now, what I taught you here, when you're cutting off, this makes the calculation so much easier, right? Now, what you guys will do, you'll have pi and pi here, you will multiply the pi, you will put 22/7, you cut off the, you don't know what you're doing also, right? So learn few things, especially simplification techniques that I teach you before you face the exam. I know that will make the getting the answer so much easier. Okay, right. So then 3x squared minus x squared, that is 2x squared. You have minus 8x minus 16, that is equal to 0. Okay, we are not done yet. Still the quadratic equation is not complete. You can see here all the terms you can divide by 2. Okay, you can divide by 2 all the terms. Now, why do I think of dividing by 2? That also, you look at the quadratic term. You try to make your quadratic terms, the coefficient, this is a coefficient, right? 2 is the coefficient of x squared. You try to make this coefficient always 1. Sometimes you can't. You leave it there, no problem. But here you can. You can divide each term by 2 here. Simply left hand side, right hand side, you divide by 2. Right? You divide the equation by 2 here. 2x squared divided by 2 is x squared. Minus 8 divided by 2 is 4x. minus 16 divided by 2 is minus 8, 0 divided by 2 is 0. Right, now your quadratic equation is complete. See there, that is the same quadratic equation they have given you on the question as well.
Why
X squared
dividing by 2?
minus 8. Yes, Shaza?
Why dividing by 2?
Why dividing by 2? Because the quadratic equation, you give it in the simplest form. Let's say your quadratic equation is 2x squared minus 3x plus 8 is equal to 0. Now here Shaza tell me, can you divide by 2 here now? Can you simplify further?
No.
No. So then your final answer is this now. But in this quadratic equation, 2, 8, 16, all of them are divisible by 2. So then let's say here you had 4. Now 4, 8, 16. Now Shaza tell me, what will you divide this equation by? Is it 2 or is it 4? Now you will divide by 4, right? Because each of the term here is divisible by 4. So you give it the simplest form. Understood? Shaza, okay?
Yes, sir.
Right, good. So then, after you get your quadratic equation, now I would say 30% of the question is complete. Or 40, let's say 40%. Okay. Now what do? You have your equation here. Now you have to find the value of x. Okay. Now to find the value of x here, I'll erase the first part. Okay. You apply the quadratic formula for the quadratic equation to find the value of x. You apply the quadratic formula. Can someone tell me what is the quadratic formula? Everyone has to memorize this. Without knowing this, you can't answer the question. What is the quadratic formula? X is equal to
minus b
minus b
Plus or
plus
minus.
or minus
plus or minus
square root
square root
b squared
b squared.
minus 4ac
Very good. Minus 4ac. That's all.
whole thing divided by 2.
Whole thing divided by 2a. If the guys who have not memorized it, write it down, memorize it. You need this. Without this, I didn't say you want this. Want and need, I hope you know the difference. You need this. Without this, you can't do the question. Okay? So then, what is this a, b, and c? I told you the general equation for the quadratic equation is what? Ax squared plus bx plus c. What is this a, b, and c? Easy. A is the coefficient. I explained you what's coefficient. Coefficient is the term with the unknown, the number with the unknown term. You can see here the number with the unknown term. Each number with the unknown term is called the coefficient. So a is the coefficient of x squared. Tell me in this quadratic equation, what is a?
X squared 1.
1. Yeah, the number with the x squared, that is a. So a is equal to 1 here. Now usually 1, we don't put 1 if the 1 is the coefficient. We don't write anything there. You have to know the coefficient is 1. Right. Now here b, what is b? The coefficient of x. The coefficient of
Minus
x.
4.
Very good. It's not just 4. We take it along with the sign. It's minus 4. Very good. So C here is the third number. What is your third number?
Minus 8.
Minus 8.
Minus 8, not just 8, right? So as soon as you get the quadratic equation on the side, you are going to write what is A, what is B, and what is C. Write this down. It's so much easier when you're in a systemic way, right? Systematic way. So then you don't go wrong. Always don't leave room for error, right? Go in a system. You do 10 questions, all the same type of 10 questions you do in a proper system. The 11th question also you will follow the same way, right? That is the muscle memory you have to build. Okay. So then x is equal to, now slowly, carefully, we are going to substitute this a, b, and c. B here, see here, minus is part of the formula, minus. Now you can see here, b is also negative, right? So what do? You follow up with the bracket, you put minus 4 here. Don't think this minus is there, so we don't have to put the minus again. No, minus here is part of the formula. If b is negative, you put the minus again. Plus or minus square root b squared. So minus 4 squared minus 4 into a is 1, c is minus 8. Divide the whole thing by 2a, 2 into 1. Okay, right. So now, what do you have to do? You just have to simplify, that's all, right? Minus into minus, open the bracket, becomes plus 4, plus or minus square root minus 4 squared. Now here, I'll ask you a question. It doesn't matter. Does it matter if it's positive or negative here? Does it matter? Your final answer will be always what? Now it's a square. You are multiplying the same thing again. Plus into plus is also plus. Minus into minus is also minus. Sorry, plus. Right? So it doesn't matter. Don't worry. Should it be positive? Should it be negative? Doesn't matter. Always going to be positive. So positive into positive is also positive. Negative into negative is also positive. So look at the number 4 squared 16. Minus into 4. So minus 4 into 1 is minus 4. Minus 4 into minus 8, that is plus 32. Divide the whole thing by 2. Now I'll ask you a question. 4 and 2. Can I just cut it off like we did before?
No.
You can't. Okay? There is an addition in between or a subtraction in between. If it was a multiplication, you can nicely cut it off. But here, you are dealing with addition and subtraction. You can't cut it off. Right? I know it's very tempting. You just see 4 and 2, you want to cut it off, but you can't here. Okay? There's addition and subtraction. So don't cut it off. Okay? Alright. So then, you have to solve the square root next. 4 plus or minus inside the square root. 16 plus 32, that is 48. Okay? Yeah, 48. Divide the whole thing by 2. Now, teach you another small part here. Right? We'll do this question and stop it. I know we have one more question. We'll carry it to the next class. Okay? So there is square root of 48. You need to find the square root of 48. Okay? The problem here, they have given you on the question only the square root of 3. See that? They have told you by using 1.73 for the value of root 3. But what we have here is root 48, not root 3. Right? So then there is something called in grade 11, first lesson that you learn is regarding surds. What are surds? Quickly, yeah? What are surds? Yes? The ones who came for the class, I taught you what is surds very recently. Not indices, no. What are surds?
Perfect square.
Perfect squares, no, not perfect squares. You are telling the right opposite of surds. Yes? Anyone? Root, what type of root? Right. So then surds are square roots of numbers which are not perfect squares. You know the perfect squares, 1, 4, 9, 16, 25. Those are perfect squares. Except those, square root of all the other numbers are called surds. Okay? So anyone ask you what is surds? Square root of numbers which are not perfect squares. Understood everyone? What are surds? Yes?
Yes, sir.
Okay. Now in surds, you have something called the entire surds. Entire surds means surds which you can simplify further. For example, if you take the square root of 5, this is a surd, not an entire surd. You can't simplify this further. But if you take, let's say, square root of 12 here. Now 12 can be written as a perfect square into a surd. Right? 12 I can write it as 4 into 3. You know 4 is a perfect square and 3 is a surd. So a number, if you can write it as a perfect square and a surd, you call it an entire surd. Okay. So then if you have an entire surd like 48 here, you have to convert it to a surd. To convert it to a surd, what do? You write it as a perfect square multiplied by a surd. So now square root of 4 is 2. So we have square root of 12 is equal to 2 root 3. Same idea here. 48. 48, you have to write it as a perfect square into a surd. Now you might ask me, sir, how do we decide what should be the perfect square and what should be the surd? They are giving you the lifeline. They are giving you the clue there. What is the surd they have given you? They have given you the surd is 3. So now you know the surd. 3 into something should give you 48. Now you just have to figure out 3 into what is 48. Right? So if you do the multiplication, 3 into 16 will give you 48. Now you know 16 is a perfect square. So then now square root of 16. What is square root of 16?
4.
Very good. 4. So now you can write 48. Okay. So your answer, this is how you do it. 4 plus or minus. Inside the square root, you have 16 into 3. Divide by 2. I'll continue it up here. Okay. So then we can write x. Now remember, all of them are x here. X is equal to, right? 4 plus or minus. Now this 16, square root of 16 is 4. 4 root 3 divided by 2. Now root 3 value is given to you. X is equal to 4 plus or minus 4 into 1.73 divided by 2. What is 4 into 1.73? 1.73 into 4, 12, 1, 9, 2, 4, 6, 6.92. So 4 plus or minus 6.92 divided by 2. Okay. So now you have two options. One is the positive sign, the other is the negative sign. Now look there, in the question they are telling you, show with reason that x can have only one value, right? With reason, show that x can take only one value. We'll see. So x is equal to 4, we'll take one the positive sign and the other the negative. One is positive. X is equal to 4 plus 6.92 divided by 2. 4 plus 6.92, that is 10.92. I'll not show you how to do the division. I'll do it a bit quick because we are late on schedule. So then we have 5 point, how much? 45, 46, 5.46. One value. The other, if you take the negative sign, 4 minus 6.92 divided by 2. Right? So 4 minus 6.92 is minus 2.92 divided by 2. That is minus 1.46. Now tell me, is x, what is x there? Can you go to the diagram and tell me what is x? X is the radius of the semicircle, right? Can you tell me, is x equal to this or this? There's only one correct answer. 4.56 or minus 1.46.
5.46.
5.46. Why it can't be the other value? Minus 1.46.
Because the
Length
length
can't be negative.
Very good, right? X is a radius. So you will tell the reason. I have told you to tell the reason, okay? So X is a radius. Write this, okay? X is a radius. It can't be negative. Right? It can't be negative. Therefore, 3 dots. Therefore, X is equal to 5.46. Therefore, X is equal to 5.46. Finally, I have told you, find an approximate value for the radius of sector B to the first decimal place. Okay, so I'll erase this. So radius B is equal to what? X plus 4. X is 5.46 plus 4. That is 9.46. Be careful. The final answer should be given to the nearest first decimal place. Right? How do we run it off the nearest first decimal place? We look at the second decimal place. If the second decimal place is 5 or more than 5, then we increase the first decimal place by 1. If it is less than 5, we leave the first decimal place as it is. Now here you can see it is more than 5. So now we increase the first decimal place. So then the radius B is equal to 9.5. Don't put centimeters. They have not given you any centimeters or meters. Is that clear, everyone? Any doubt here you want to ask me, please, you're welcome to ask doubts. Can't you divide before multiplying by 4 by both the sides? Can't you divide before multiplying by 4 by both the sides? Where did we multiply by 4 on both the sides? Which one? No units, no units. They have not given units, right? So don't take the units. The one who sent me a question, can't you multiply both sides by 4? I didn't understand. Can you repeat it back again?
Sir, we can get rid of the 2, no? The denominator.
Yes. Right? I know what I'm asking for. You are saying this 4 also you can divide by 2, 6.92 also you can divide by 2. That's a question. Is that what you're asking? Or are you saying 4 and 2 you can cut it off? Amani.
No, sir, I told to get rid of the denominator too.
So to get rid of the denominator too, okay. What I suggesting?
We can get rid of it, no, by doing that, multiplying the
Taking
entire
the two.
and then cutting those two off.
By multiplying by 2. Where are you going to multiply? Cross multiply. Are you asking me?
Sir.
Cross? Ashifa,
Sir,
yes.
to get rid of the denominator, can we take the 2 as a common factor?
Yeah,
cut
that you
it?
can do. Right? So you can take the 2 as a common factor. Now, before going further, 4 and 6.9 to take 2 as a common factor. 2 plus 3 point, how much? If you divide by 2, 3.46. 3.46 divided by 2. 2 and 2 can cancel it off. You can do that. By the extra work, this should be fine, right? Okay. You can do it, no problem. Okay, we'll stop here, right? The next class, I'll do the question and I'll send you more questions. Next class, don't worry, we'll start at 10. Okay, to be honest, I also fell asleep, right? I was waiting to start the class. I already, by 9:50, I started in the Zoom link and I fell asleep. I should be honest, right? Okay, so then I woke up all of a sudden at 10:15. And so the time is 10:15, already 100 people are full. And you guys are calling me saying that you can't join the class. Then only you guys only woke me up, right? So next class, don't worry, start exactly at 10. I'm also getting used to the shift, right? Okay then. If you have any doubt, please do ask me on WhatsApp also. Anytime you guys are welcome to ask any doubts. Privately message. You can't message on channel, right? So drop a message, any message that you have, any doubt that you have. Hopefully, I'll get it cleared off. It takes a bit of a time.
So for next class also, I want you to do another quadratic equation.
Yeah, we'll do the quadratic equation that we had already planned for this class. We have one more, right? So we'll do that. Along with that, we'll see. I'll decide whether we can do a quadratic equation. We have fractions, area, lot to discuss, right? So in these 3 weeks, I'll send you guys a plan on what we are going to do, and hopefully we'll cover a bit of everything. Okay?
Yeah.
Right then. Good night, or should I say good morning? So it's the next day.
Thank you,
Right?
sir.
Okay, you're welcome. Take care,
Good
guys.
night.
Good night. Good night.
Assalamu alaikum, sir.
Learning, sir.
Waalaikumsalam. Bye, guys.